Hey guys, I'm going to show you what I got for the 5-switch enumerator project. The goal is to design a digital logic for a 7-segment display to show how many of the 5 switches are turned on. So let's try it first. I chose switch 1 to switch 5. And when there are no switches turned on, I should get a 0. And when I turn on any of them, I should get 1. And when I turn on 2 of them, I get 2. And 3, and 4, and 5. So this is the approach 1. I draw a truth table for the 5 inputs and the 3 outputs. And I actually add the numbers of ones for x1, x2, x3, x4, and x5, and get the binary numbers of the total for f2, f1, and f0. So I draw the k-maps for the outputs. This is for f2. Because I have 5 variables, I choose to separate it to 2 different k-maps. And I can write the expression for f2 here. And f1 here, and f0 here. I can get 16 main terms because there are 16 ones here. And these 3 expressions are either a minimum SOP or POS. And I calculate the total cost of this approach is 309. It's a lot. And this is the code for approach 1. And I can compile it and get the total logic elements is 7 and total pins is 8. These 2 numbers does not include the 7-segment display. And this is the RTL diagram. It's complicated. So let's move to the approach 2. So here is the approach 2. I use the hierarchical implementation. So I split up the set of 5 switches into a set of 2 and a set of 3 switches to make it easier. And for x1 and x2, it's actually a simple half adder. And I can get a sum S0 and a carry S1. And for the set of 3 switches here, I need to use 2 half adders connected to each other and draw the diagrams of the 2 half adders. Firstly, I put x3 and x4 into the first one to get a P1 sum and a P0 carry. And then add x5 into the second one to get a sum S2 and a carry C out. And here is the code for the approach 2. You can see this is the first module for the set of 2 switches, and this is the full adder. And in the full adder, I call the first one here. It's simpler. And then I need to draw the k-maps for f2, f1, and f0. They are the outputs I need, and I have 4 inputs here. So I need to add the four two-digit numbers together. And because S0 and S1 are numbers here, because I have only 2 switches, so I only have maximum 2 switches on, and it in binary number is 1 0, so I don't care the 1 1, so I don't care them here, here, and here. Then I add S0, S1, and S2 C out. Then I can get the expressions for F2, F1, and F0. And then I can compile it and get the diagram here. It's the header here. Then approach 3. Approach 3 is the simplest method because I use the sum operation in Verilog. So the code can get the sum of 5 inputs and return the total binary number. It's here. The input are the 5 switches and the output is 3 outputs here. And I can simply use this term here, add them together. And finally, I linked the F2, F1, and F0 to the 7-segment display by using the choose table here. For this diagram here, I need to write down the expressions for A, B, C, D, E, F, G. And here. Assign them to the expressions they need to be. And it's simply like this. That's it. Thank you.